Let's talk about vector databases, what they are, how they work, and why they're suddenly everywhere in the world of AI and data. In traditional databases, we work with rows and columns. Structured data, where you search by exact matches, filters, or numerical comparisons. But when you're working with AI, especially large language models or image recognition, you need something completely different. That's where vector databases come in. A vector is just a list of numbers, but in AI, it's a representation of meaning. For example, when you feed text, audio, or an image to a model like OpenAI's, it can generate a vector, a numerical representation of that input. That vector can then be stored and searched inside a vector database. Unlike traditional search that checks for keywords, vector databases perform similarity search. That means you can ask questions like, find me documents that are conceptually similar to this paragraph, or find images that feel like this one, even if they don't contain the same words or exact pixels. So how does it work? You start by embedding your data. That could be chunks of text, product descriptions, support tickets, user queries, etc. You pass each chunk through a machine learning model that converts it into a vector. Those vectors get stored in the vector database. Now, when someone submits a query, like a user asking a question in natural language, you embed the query the same way. Then instead of filtering through exact matches, the database performs a nearest neighbor search in the vector space. This type of search is fast, scalable, and works great for use cases like semantic search for documents or FAQs, image or audio similarity recommendation systems, context retrieval for LLMs like RAG pipelines. Vector databases also support metadata filtering. That means you can combine semantic similarity with filters like language, author, or date. It makes the experience much more powerful. Some popular vector databases include Pinecone, Weaviate, Face, Milvus, and Qdrant. Many of these are open source or offer hosted versions with APIs. To sum up, vector databases store high-dimensional vectors instead of rows and columns. They power similarity search, which is crucial for modern AI applications. They're used to support natural language interfaces, search, recommendations, and more. Thanks for watching Big Data Now. In the next video, we'll show how vector databases integrate with large language models for real-time context retrieval.